In this video, we're going to learn another way to find roots of polynomials or zeros of polynomials, and this is called the rational root theorem. Remember, rational numbers are any numbers that can be written as a ratio. So 0.5 is a rational number because we can write it as 1/2, and 1/3, even though it's a repeating decimal forever and ever and ever and ever, it still is a rational number because it can be written as a ratio. So this does not include any sort of zeros that would be irrational, like square root 2, or imaginary zeros like plus or minus 2i. But it can give us some more insight, okay? It can help us to narrow it down so that we can use other things that we know. The first step in our warm-up that we're going to do is to divide this polynomial by x plus 1. There are two ways we could do this. We could do long division by putting the factor out here and the polynomial under here. But because this is in the form x minus k, this one is ideal for synthetic division because there's no number in front of our x. And synthetic division is of the form dividing a polynomial by their x minus k. So when we divide synthetically, we'll put k out here, and then the coefficients of this polynomial will go inside. 3, -2, 2, -5. Now, if it's in the form x minus k, that means that x plus 1, k is the opposite sign. K is going to be -1 because only x minus -1 could have simplified to x plus 1. And that would be your form x minus k, which gives you -1 for k. 3 times -1 is -3. Add. -2 plus -3 is -5. -5 times -1 is 5. Add. 2 plus 5 is 7. 7 times -1 is -7. -5 plus a -7 is -12. You're not done. Your answer is not 3, -5, 7, -12, okay? These are just the coefficients. That's the convenient thing about synthetic division. You don't have to write all the x's. But when you give your answer is a polynomial, okay? And if your original polynomial was x cubed and you're only dividing by a factor that has x to the 1 in it, that means the degree of this polynomial of your answer is going to be 3x squared. It's going to be 3 minus 1. Taking those exponents, it's always just 1 less the original degree. So 3x squared, and then -5 is the next coefficient, so that's attached to x. 7 is the next coefficient, and that does not have an x, so it's the constant term. And then our last number here is called the remainder. So we write this as minus whatever our remainder is, because our remainder here is negative, otherwise it would be plus. And then the denominator of the remainder is actually the divisor. Now, -1 is not the divisor. -1 is k. What we're dividing by when we write -1 off to the side, we're dividing by x plus 1. So that must be our denominator, x plus 1. This is the polynomial you get when you divide this by this. Determine if d of x is a factor of f of x. Now, anytime you determine if something's a factor, let's say I'm dividing 21 by 4. 4 goes into 21 5 times, and then there's 1 left over out of the divisor, which is 4. Okay? 4 is not a factor of 21 because it didn't divide evenly. So only when you have no remainder, will you truly have a factor. Okay, this number at the end of your synthetic division, in order for it to be a factor, must be 0, meaning it divided evenly and has no remainder. So let's begin by synthetically dividing this. Just remember that if they had 4 and then a 2, like they didn't have this term at all, that you would need to put a 0 in that spot as a placeholder. That's something that many people forget with synthetic division. If we're dividing by x plus 6, then k is negative 6. If we were dividing by x minus 2, then k would be positive 2. Synthetic division is like dominoes. The first one has to fall to get things started. So you have 2 times negative 6 is negative 12. 7 plus a negative 12 is a negative 5. Negative 5 times negative 6 is positive 30. Now we're adding negative 27 plus 30. That's 3. 3 times negative 7 is negative 18. 17 plus negative 18 is negative 1. Negative 1 times negative 6 is 6. Negative 6 plus 6 is 0. Yay! So x plus 6 is indeed a factor of this polynomial. And what is the remaining polynomial? Okay, what is the answer after you've divided out the factor x plus 6? Well, the original degree was 4, so the answer degree will be 1 less than that, so 2x cubed minus 5x squared plus 3x minus 1, and as you can see, 0, no remainder. Awesome. The rational root theorem states that if f of x is some polynomial, okay, a sub n is known as our leading coefficient. A sub 0 is the last term written in descending order. That's the constant, the number that doesn't have an x attached to it. Remember, descending order is writing the largest exponent to the smallest exponent. If the polynomial has integer coefficients, not fractions, not radicals, then every rational solution of f of x equals 0 has the following form: p over q, factors of the constant term a sub 0 over factors of the leading coefficient. So what we need to find out is what are the possible forms that our rational zeros could take. So a sub n is right here. That's 2. A sub 0 is also 2. 2, negative 2. The signs we are not concerned with when picking out factors because we will pick positive and negative. We'll cover plus or minus for everything. So p is all the factors of a sub 0 and q is all the factors of a sub n. And this is written as a fraction. What are the factors of negative 2 or just 2? That would be plus or minus 1 and plus or minus 2. And then q covers the factors of a sub n. What are the factors of 2? Again, there are plus or minus 1 and then also plus or minus 2. So the rational zeros will all take this form. To find the possible rational zeros, we need to combine each numerator they've given us with each denominator they've given us for all the possibilities. Plus or minus 1 over plus or minus 1 is simply plus or minus 1. Plus or minus 1 over plus or minus 2 is plus or minus 1/2. Plus or minus 2 over plus or minus 1 is plus or minus 2. Plus or minus 2 over plus or minus 2, well, that's just plus or minus 1, which we already have here. So our possible rational zeros are plus or minus 1, plus or minus 1/2, and plus or minus 2. In order to test them out to see which ones are actually zeros of this particular polynomial, we're going to use synthetic division. start with the coefficients of the beginning polynomial, 2, 3, negative 3, negative 2. I'm going to divide by positive 1. See where that takes me. Drop the first one like dominoes. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. 5 plus negative 3 is 2. 2 times 1 is 2. Plus negative 2 is 0. Wow, ding, ding, ding. We got one on our first try. So 1 is an answer to this polynomial. It's a 0. It's a root to this polynomial. But what are my other ones? Well, this has left us with a quotient, an answer, which is also a polynomial. And the degree of this polynomial is 1 less than the one we started with. So 1 less than 3 would be 2. 2x squared plus 5 times x plus 2. This is our quadratic that we need to solve. In order to solve it, we're going to try factoring and make it equal to 0. 2x times 1x gives me 2x squared, and 2 times 1 gives me 2. And whatever I get needs to add up to be positive 5x. So multiplying across the diagonal, you get 2x times 1 is 2x, and x times 2 is 2x, but those aren't going to add up to be 5x. So we're going to change the order of these. 2 times 2x is 4x, and x times 1 is 1x. Those do add up to be 5x if it's all plus. Okay, so top row times bottom row is how this quadratic factors. 2x plus 1 times x plus 2. And from here, let's use the zero product property to solve for our remaining zeros. Subtract 1 on both sides and then divide by 2. So x would be negative 1 over 2. And then subtract 2 on both sides, x equals negative 2. Our possible rational zeros were plus or minus 1, plus or minus 1/2, and plus or minus 2. Our actual rational zeros are 1, negative 1/2, and negative 2. So these are all the rational zeros. Are these all of the zeros of this polynomial? The degree tells us that. This is a cubic function, so it should have 3 answers. And what did you come up with? 3 answers. So yeah, all the zeros of this polynomial are also rational zeros. This also helps me with the beginning function's factorization. 1 is a 0 of your polynomial, so x equals 1. But how do I write that as a linear factor? I'm going to subtract 1 on both sides. X minus 1 equals 0. This is how it was before the person solved and used the zero product property. So x minus 1 is the factor that goes with positive 1 as a 0, which makes sense because it's in the form of x minus k for synthetic division. When we checked to see if 1 was a 0 of this polynomial, we were dividing it by x minus 1. And that turned out to be a factor, which left us with a trinomial, a quadratic trinomial with 0 remainder. And when we factored that trinomial, we ended up getting 2x plus 1 times x plus 2. So the full factorization of the beginning polynomial is this. That was not asked for in the directions, but it's another benefit of the rational root theorem. 14 is a sub 0, and the coefficient here, which is 1, is a sub n. So p over q, the factors of a sub 0 are plus or minus 1, plus or minus 2, not 3, not 4, okay, only 7 and 14. And the factors of a sub n are just plus or minus 1. Okay, this one's going to be pretty easy. Just each of these needs to be divided by plus or minus 1, which leaves it as it is. So plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. These are my possible rational zeros. I'm going to begin by testing out 1. So my coefficients, just like dominoes, the first one's got to fall. 1 times 1 is 1, 6 plus 1 is 7, 7 times 1 is 7. 7 minus 23 is negative 16. Negative 16 times 1, negative 16. Nope, that's not 0. 1 is not an option. Let's try negative 1. Just like dominoes, the first one has to fall. Negative 1 plus 6 is 5. 5 times negative 1 is negative 5. Negative 5 plus negative 23 is negative 28 times negative 1 is positive 28. Nope, that one doesn't work. Let's try 2. Drop the first one. 1 times 2 is 2. 2 plus 6 is 8. 8 times 2 is 16 plus negative 23 is negative 7 times 2 is negative 14. 0. What up? Woohoo! We found it. We found a factor. We found a 0. Okay, so this means that 2 is a 0 of our polynomial, which in turn means that x minus 2 is a factor. Let's see if we can factor the rest. 1 x squared. Okay, we started off with cubic, so this is a quadratic. X squared plus 8x minus 7 to get any other rational zeros. Two numbers that multiply to give me negative 7, and those same two numbers need to add to give me positive 8. So negative 7 would be like, it's 7 times 1, so 7 times negative 1, or negative 7 times 1. Neither of those gives me positive 8. So it's like you're so close, but the signs are off. This is not a factorable quadratic. When you factor the original polynomial, again, because 2 was a 0, that means x minus 2 is a factor, and then we still have this quadratic factor, but it's not factorable. So we can't break this down further. So if they asked you for the complete factorization as irreducible linear or quadratic factors, then this would be your answer. But here's the thing. They asked us to find all possible rational zeros and then all rational zeros. We found the possible rational zeros, and then we tested out 1 and we got it, but we haven't found the others. If there are others, if this right here is not factorable, then it's not going to give you any more rational zeros. It's still going to give us zeros, probably with quadratic formula, completing the square, but those zeros will not be rational. So when you say x equals 2 is all the rational zeros that this polynomial has, that is true, because even though it has 2 other zeros, they are not rational, so you don't have to find them. Not in this lesson.